Hello students and friends, welcome to my YouTube channels. Now again I came for one more heat transfer problems. So these problems I taken conductions and convections both mixed together. So these problems is based on the conduction and convection. So before in our video already formula and all I discussed if conduction single wall, composite wall or if conduction convections mixed together will be there, how to solve, how to write the formula, how to draw the diagram and how to process the solution. So see this question. All the data will transfer into the diagram. All the data will transfer into the diagram and one by one steps will solve these questions. So what is given? A wall is constructed of the several layers. It's more than one layer. The first layer consists of masonry block. So first of all draw the several blocks they are asking now. So first one block. First block, what is thickness given? Centimeter, 20 centimeters, so 0.2 meter, that is called L1. And thermal conductivity they given, K1 is 0.66 watt per meter Kelvin. The second layer consists of 3 centimeter thickness. Okay, take the L2 is 0.03 meter. 3 centimeter divided by 100 is called 0.03 thickness. That is called thermal conductivity will be 0.6. K2 is equal to 0.6. Third layer 8 centimeter. Again one more layer because several layer already told. So how many layer? 4 layer will be there. 0.08 meter. These all are coming meter. I am not writing, all the dimensions are in meter now I am converting. And thermal conductivity K3 will be 0.58 and the outer layer consists of 1.2 centimeter thickness. One more layer will be there. Thickness is 1.2, 0.012. 1.2 divided by 100, 0.102. This thermal conductivity they given K4 0.6 watt per meter Kelvin. And the heat transfer coefficient they given, that means inner and outer layer they given. So once heat transfer coefficient given, that means we know this is the convection part. So heat transfer coefficient HA, what is given? Because one side we taken HA they given 5.6 watt meter square Kelvin. Heat transfer coefficient unit is watt per meter square Kelvin. Now HB they given 11 watt meter square Kelvin. Okay, now temperature they given TA 22 degrees Celsius. If we'll convert into the Kelvin, it will come 295 Kelvin. 295 Kelvin. Then TB, TA, then TB, outer layer. You can write TI, T0, nothing wrong, inner and outer, TA, TB, whatever notations you are comfortable, you write. TB will be 268 Kelvin. So conductivity I replace from the problem to diagram, length given. Okay, now they are asking. So once I'll read the questions. A wall is constructed of several layers. The first layer consists of masonry block. This is masonry brick. Then the second layer thick. The thermal conductivity 0.66 watt meter Kelvin. The second layer consists of 3 centimeter thick mortar. MORTAR, mortar. Conductivity is thermal conductivity given 0.6. Third layer consists of 8 centimeter thick, that is thermal conductivity 0.58 limestone. That is given limestone 0.58, correct. And outer layer consists of 1.2 centimeter thickness plaster. This is given plaster 1.2, so 0.012. Then exterior interior heat transfer coefficient given. This much given. What they are asking, calculate the heat transfer coefficient, overall thermal resistance, overall heat transfer coefficient, temperature between the junction of mortar and limestone. If they'll ask temperature, what is the interface temperature here? Interface temperature you give T1. We'll write some different colors. It will be looks good. All interface temperatures I am going to write here. But what temperature they will ask, that you have to find out. So this is T1, this is T2, this is T3, this is T4, this is T5, this is TB, this is here TA, temperature is TA. So all the interface temperature nothing but T1, T2, T3, T4 are interface temperature. But what they are asking, temperature between junctions, mortar and, so that means they are asking only T3. So T3 is asking that T1, T2 also we have to find out. If they will find all the interface temperature, so T1, T2, T3, T4, T5 can find. So whatever they are asking, that only we will find here. So okay, so now first what they are asking, rate of heat transfer. So now see here, in diagram itself little will modify. We will write the equivalent resistance diagram. See here, this point is nothing but TA. Then here thermal resistance. What is thermal resistance? You can write RA. Then this will be nothing but TA, you write somewhere. So TA, this point is TA. Here RA is equal to 1 by HA into A. RA. So now next, thermal resistance, what is R1? R1 is nothing but K1 L1 by K1A. See what we know, Q is equal to, suppose one block is there, T1 T2, K1 L1. So T1 minus T2 by L by Ka. What is L by Ka? Thermal resistance, that also told. So this concept only we write here, for one block thermal resistance. Here 1, 2, 3, 4 block 5. Both places are what is the thermal heat transfer coefficient given? So RA is equal to 1 by HA. This is convective heat transfer. Here also convective last. 1, 2, 3, 4 is conductive heat transfer. So L1 by Ka. And if you write convective heat transfer, HA, T1 minus T2, suppose one block is there. So what is heat transfer here? Q is equal to T1 minus T2, 1 by HA. So what is this one? Thermal resistance for the convection. This thermal resistance for the conduction. So thermal resistance for this convection, this thermal resistance for the conduction. Similarly, all you write here. So based on this concept only we can solve. We can remember the steps K2, A2. Now what is this one? R3, L3, K3A. Then R4, L4, K4A. Then again here temperature will come T5. So here thermal resistance. So what is this one? R5. What right? L5 by K4, K5, L1, L2, L3, L4, T5. T5 by K5, K1, K2, K3, K4. So L1, L2, 4. So this will come R5, no? T5. So here it will come only L5. So this will come RB. This we can write here RB. RA, RB convective thermal resistance, R1, R2, R3, R4 is conductive thermal resistance. So it will come RB is equal to 1 by HBA. HBA. Okay, this only is the circuit diagram. Everything we transfer in this diagrams. Okay, so now look here. How to write now? How to solve this question? So see, once this wrote, almost 50 to 60% work over. Now first one will solve. What is this first one? Heat transfer rate, Q equal to, so heat transfer rate they are asking, rate of heat transfer. So Q by A equal to overall temperature, what is? TA minus TB. TA minus TB, overall temperature. Then all the thermal resistance will write here. What is here we write? You write here RA plus R1 plus R2 plus R3 plus R4 plus RB. We wrote. These steps you can ignore also, but I am writing for your understanding here. What is this one? TA by TB? 295 minus 268 divide by, what is RA? RA nothing but 1 by HA, because here A already taken, because heat flow rate, so A will not come here. What will come? 1 by HA. We'll write directly value now. 1 by, what is this one? RA, R1, R2, R3, R4, everything you know. So directly I am writing value. What is this one? RA is equal to 5.6 plus R1, L1 by K1. What is L1? 0.2. What is K1? 0.66 plus, what is 0.03 R3, R1 over R2 will be 0.03. Then what is K2 here? 0.6 plus 0.08, this is R3. So 0.08, what is K3? 0.58 plus 0.012, what is this one? Thermal conductivity 0.06 plus 1 by 11, thermal conductivity 11, heat transfer coefficient. So this is the heat flow rate. This is nothing but Q by A only. If you will calculate this, what you will get? Heat flow rate. So these answers will come. Already we calculated this answers is coming 34.56 watt meter square, because heat flow rate watt meter square. Now thermal resistance, overall thermal resistance. What is overall thermal resistance? You see here, overall thermal, this is first one, second one. Overall thermal resistance nothing but RA plus R1 plus R2 plus R3 plus R4 plus RB. So all the value you will write this and you will add and you will substitute the value. Area will take it, because the given per heat transfer, rate of heat transfer, that is area will be 1 meter here. So RA what will come here? I will write 1 steps or directly will write the value. So once you have calculated this part, I will show you. If you are calculating this part here separately, that is called total thermal resistance. If this part you will write here, directly I am writing answer, because you have to do the work. So what you have to do? This total is known as overall thermal resistance. So this answer is coming, already we calculated. Overall thermal resistance answer will come 0.78 watt, Kelvin by watt. Answers will come. Okay. So overall thermal resistance. So these two ones they are asking, heat flow rate or heat transfer. Thermal resistance always you calculate separately and keep ready. Suppose they are asking overall thermal resistance, this part is known as answer. Now third one, what is asking? Overall heat transfer coefficient. That also will be very simple. See here, overall heat transfer coefficient third one. What is? Q by A equal to UA overall temperature TA minus TB. TA minus TB we know, Q by A we know. Q by A we know. So this Q by A will not be here. Q by A I know. So overall heat transfer equal to what will come? U equal to this value you know. Okay, write this value one time. 34 point, where I wrote the value? 34.56 equal to U into, what is temperature? 295 minus 268. 295 minus 268. If you will divide this value to here, you will get. You will get how much value I calculated? U value I calculated 1.28. 1.28 watt meter square Kelvin. Watt meter square Kelvin. So overall heat transfer coefficient I got. Now see, suppose if you will see the book solution, if you see the book solutions, it will go 2 to 3 page. How to solve this? If heat transfer problem you want to see, you solve, don't fear first the given problem. This problem itself half page. Read this problem, transfer all the data into diagram, write all those things how I wrote, take the one content and solve this. So see 1, 2 and 3, this over. Now temperature between the junction of the this, that means they are asking interface temperature. So another 2 minutes we will finish this question. So up to this over, now I will rub it this question, then we will find the interface temperature. Now I will find the interface temperature. Suppose they are asking find all the interface temperature, that you can find. Only one they are asking, then also we will find. So how we will find? For interface temperature calculation. See, I wrote. Now what will write? Q by A is equal to TA minus T1 by 1 by HA. HA. What is this one? Thermal resistance, RA, equal to T1 minus T2, L1 by K1, L1 by K1, R1, thermal resistance. Then T2 minus T3, L2 by K2, equal to T3 minus T4, L3 by K3. What they are asking? They are asking only T3. So where is the T3 here? So this also not required. But Q by A is equal to this, Q by A is equal to separately this, Q by A is equal to separately this, Q by A is equal to separately this. That means this all will be equal. So if you want to calculate first T3, directly you cannot calculate. What you have to calculate? T1 and T2 you have to calculate. So what we will do here? You will consider first 1, 2. So Q by A. Q by A. What is Q by A here? 34.56. So directly I am writing 34.56 equal to TA. 295 minus T1 divided by 1 by 5.6. So you will get from here T1. You will calculate here T1. So how much T1 I calculated? I will write here. T1 I calculated 288.8 Kelvin. 288.8 Kelvin. Now what we'll do? We'll consider these two, Q by A and this second part. So this is first one. Second will be what is? Q by A into this. So we'll write one time for your understanding. Q by A is equal to T1 minus T2 by L1 by K1. That implies 34.56 equal to T1 I know. 288.8 minus T2 divided by T1 minus T2. So L1, what is L1? 0.2 by K1, 0.66. If you will calculate here, you will get the T2. You will get the T2. So that also I calculated. I will show you 34.56, 0.2 by 66. So T2 we got 276.6 Kelvin. So we know now. Now final, what will do this? Third one. So I am writing here. Again Q by A equal to, you take T3. So T2 minus T3 by L2 by K2. If substitute the value, T2 value 273, Q by A is equal to 34 point this. So you will get here T3. So that T3 will be your answer. So T3 how much we calculated? 276.6. 276.6 Kelvin. So they are asking only T3, but T1, T2 automatically we have to find out, then only we can calculate T3. If they will ask between temperature limestone and plaster of Paris and maybe exterior, so T4, T5, limestone plaster T4, mortar and this T3, masonry and mortar T2. So whatever they will ask, we can calculate T1, T2, T3. Okay. So see this question. If you'll see the book solutions, it will be very long. So this way you can, big questions, this concept you can solve. Okay. So these questions, take your notebook, copy down first beginning to end, similar way, and check the calculation. Don't believe my calculations are almost correct only, but you calculate and check the calculation part. Concept will be same. Calculation part you cross check and revise this. Okay. Don't forget to subscribe the channels. Okay. Okay, friends.